Hey guys. Oh, the sun is pretty high. How are you? All good? So let's get started. So today I will first start with an introduction of me. So I'm Simon Melotte. I work at Palo Alto Network as a Prisma Cloud solution architect. So today my focus is mainly about everything which is public cloud, Kubernetes, OpenShift, and all the automation. And yeah, you can connect with me on LinkedIn if you want, just like Simon Melotte, and that should be good enough. Or that was the animation of the day. So that the least you want once more maybe? Yeah. There you go. Yeah, that's it. No animation anymore. So, and today I really want to talk about public cloud, cloud native application, I would say. And it's about the fact that they are in the art of the digital transformation. And indeed, we know that at least I used to do some lift and shift migration, so migrating like a VM to Azure to AWS and stuff like that. And then once they're there, we try to implement some digital transformation, so using like microservice architecture and this kind of stuff. So what is the requirement of it? It's going to be like some kind of elastic network, the VPC, the VNet, and this kind of technology. Then we'll need like dynamic workloads. We'll go maybe still on virtual machine, but then we'll try to migrate to container, serverless. That will bring some complex identities. So that means maybe now a virtual machine will assume a role of having access to a certain S3 bucket or like a storage account or something like that. So you have to, we have to learn that. We need to manage those identities. But when we do like migration from one application, it's going to be fine. But when you do like migration of 100 applications, then it becomes really complex to manage. And of course, growing data stores like RDS database could be like, just an S3 bucket, a cloud storage account, and this kind of stuff. It brings a lot of advantages. Obviously, we can scale up and down very fast, so that's very good. It can help us to better utilize our resources that we consume, maybe reduce a bit the cost. And it gives us also the possibility to have like self-service portal. And also like operational efficiency. But those cloud-native application, modern application, I would say, they bring like security risks. And that's where I want to focus today. I just wanted to set a bit the context of it. And here we have like typically the application lifecycle that we have when we do the development of an application. So on the left, you will have like the code and build. Then with obviously the code, and then we have like the custom dependencies that we bring into the code. We have the source code of it, of course, and we could have like infrastructure as a code, something like Dockerfile, Terraform, might be like Kubernetes definitions and stuff like that. Then we have the deploy phase. That's where we will package the software. We'll do the connection with the CI part, and we'll do the deployment of the application. And then obviously we have the running phase. So those are the running application where we find our elastic network, the dynamic workload, and they can run on multi-cloud environment, or maybe they will run also on private cloud. So it's all about, it could be like hybrid cloud infrastructure and so on. Those, and here I want to give you like a real life example of the risk that we saw last year, for example, on the 14th of December. Maybe, I guess you are all aware of it, but we had like a log4j vulnerability. And then, and sometimes we don't even know that when we bring a dependency, or like a Java application and so on. So we bring a dependency in the pom.xml, and then this dependency will use log4j on the backend, and we don't know which version and so on because it's not always visible for us. So that's something like a risk. And of course, you need also to be able to discover where those dependencies are running and so on. Then on infrastructure as a code, we have we scan as Palo Alto Networks organization. We scan the 3000 file on the Terraform registry, So we took like, but maintained by HashiCorp, so should be like a good level of one, and at least 44% contain already a misconfiguration. So that means, I don't know, maybe an S3 bucket which is widely open or something like that. So this is what we discover. So 44% of the out of 3,000 infrastructure as a code file were containing at least one misconfiguration. Then, and I guess you know the distribution Alpine, which is really a lightweight that you can use to deploy your application, like a Docker container image. And there we discovered that during the deployment, so people were using the base image Alpine, and the package manager could, at the build phase, could allows the attacker to intercept and inject malicious code. So really at the build phase. And then, of course, those applications, they are built, and then they are shipped to production. And then if you don't have something to scan, you don't know that you are vulnerable from the beginning of your Docker file. So this is something could be like potentially dangerous. And then on the running instance, for running application, then we have like plenty of example. That's all the stuff we see in the newspaper. For example, I took a couple of them that was quite important, I would say. And for example, here an attacker just stole an AWS credential, and he get access to an employee that had access to an S3 bucket where there was like credit card numbers, credit card application. And the guy just the attacker were able to store like 23 million of dollars, and then the company was fined with 80 million. So this is like real life example. This one was in US, but the other one was like a cryptojacking. Cryptojacking stuff. So basically, the attacker were able to get access to an access keys, and he started like deploying a lot of different infrastructure. And you need, of course, that's something that you discover like on a GitHub public repository and stuff like that. You find like a AWS access keys. And it happens that we push like secret information, sensitive information inside a repository, like a private key, maybe a password or something like that. And then or maybe it will be in the history of the repo. And then this one, with the access key, he was able to create infrastructure, and it cost to the company like almost 800,000 euros. Just a couple of examples. And I want here with this slide, just want to recap a bit what are the different risks that we see in each different stage of the development lifecycle of an application. So here it's like mainly gonna be like on the coded build phase, we'll have like vulnerable code. We have like infrastructure as a code, which is misconfigured. We have like maybe a secret, which would be exposed in a public repo, something like that. Then on the deploy phase, we could have like malicious image, or the base image that we take, which is already compromised, and we don't know about it, obviously. Then we have like a insecure CI/CD pipeline, and then on the run phase, we'll have like, for example, overly permissive access. Typically, if you are running like a serverless, and also the story with the assume role on the AWS, so you will provide access to a workload, a Lambda function, an EC2 instance, or something like that, or a container that can have access to like an S3 bucket or something like that. And then this one might be, instead of being, we provide the access to the specific bucket, and we'll provide like a wildcard permission, and then those are the overly permissive access. And then malicious web attack, data exfiltration, that's everything we see in the newspaper. When the attack is successful, then we'll say, usually we'll see it there. All right, so then I'm working for Palo Alto Networks, so I will talk about the Prisma Cloud capabilities. So it's our product that we develop internally. We did some acquisition as well. But the idea is that for every stage, we have different capabilities into Prisma Cloud that will help you to better secure your supply chain and stuff like that. So, and for example, we'll have different possibilities to secure the code. For example, what we'll do there, we will install an extension on a VS Code or IntelliJ where you can just connect with an API key to Prisma Cloud, and you will fetch the policies from Prisma Cloud, and you will not enforce them, but you will warn the developer if it's not following the policy that we design on the Prisma Cloud platform. And I will show you that later. This is, I think, my last slide. Yeah, maybe I have one extra, and then I will jump into a demo just to show you a bit the feeling of the developer when you work in a VS Code and stuff like that. Then what we can do with Prisma Cloud is software composition analysis. And the idea is that we'll scan the code dependency file to scan for I don't know, like vulnerable dependencies and stuff like that. We'll scan also the code repo for the secret scanning, so we'll be able to discover if you have like AWS access keys, Azure key, private key, or like just entropy string. If you have whatever secret password inside your code, we'll spot it and we'll give a warning to the developer if he has installed the checkoff extension. Then we'll have like vulnerability management and compliance. And the idea is that we can integrate with inside the CI/CD. We can integrate with whatever CI/CD do you use, you will use. It could be like a GitHub Action, GitLab CI, Jenkins, Azure DevOps, this kind of stuff. So we can really integrate there and connect and scan already your code repo. We can scan as well the image that you built. So when you do the build, Docker build command, then we will be able to scan the Docker images to see what are the vulnerabilities. And then we can fade the pipeline if they are not compliant to the policy that we implement, again, on a Prisma Cloud platform. Then I will not go through all the points, but maybe the interesting part on the deploy phase is going to be the image analysis sandbox. So the idea is that during the CI/CD, we will sandbox the container image that you just built, and we will run it for like a certain period of time. Could be like 10 seconds, 30 seconds, 10 minutes if you want to. And the idea is that we will monitor every action which is taken during the boot of the container, during the time that you give to the container, to see if it is, what is the behavior of the container. And so, for example, if you have like a malware that starts after like 2 minutes, we will see it, we'll spot it, and we will alert you into the Prisma Cloud platform. And we can fail the pipeline as well, obviously. This is like, and then if it is okay, you can add the image in what we call a trusting group. And the idea then is that you have Prisma Cloud that will allow for a certain namespace or a certain Kubernetes cluster only images to be deployed from a certain container registry. So that means you have a namespace, and you know that in that namespace it should come from a trusted container registry. Then you can limit those stuff. And then on the run, there is many more capabilities, but I propose that I will jump right on just the next slide. Palo Alto Networks really like cybersecurity company focusing on different, just the security aspect of digital life, I would say. And the idea is that we have the threat intelligence stream that will be sent to the Prisma Cloud platform with all the information that comes from different products of Palo Alto Networks. And we have also, which is interesting, the Unit 42 threat research. So we have teams which are looking for really like threat, which is a bit like red team, blue team, and stuff like that, really focusing on looking about the threat on the landscape, listening on the dark web and stuff like that for the new techniques which are used by the hackers. So it's really like a team that will then provision and help us to improve the security inside the Prisma Cloud platform. So with no more slide, and sorry, one more slide. this one, but it is to explain a bit the workflow of the demo I want to show, and at least because I really wanted to show how simple it is to include security into the CI/CD platform. So, and here I decided to do it on a GitHub action, but it could be like on anything. And so first step that we'll do in the GitHub action is going to be checking the infrastructure as a code. So we'll check if the Docker file of the Spring Boot application is OK or not and stuff like that. Then we'll check the code dependencies of the code, and those are the different files that you can check. So for example, we have the GoSum for the Go language, then we have the Gradle, we have the pom.xml, we have the different package.json and so on, and we have also everything which is requirement.txt. Then we will analyze with a Sandbox the image that we built, and we will collect the information about the binaries and send it to Prisma Cloud Console to have like an analysis about the vulnerabilities. So if I jump into the demo, here I am. So this is like GitHub action. Is it OK to read, or should I zoom a bit? Yeah, no, it's OK. OK, thank you. So here you can see that I have a task in my. So I have a pipeline which is, and here I have a job, and here I have a task which is from a checkoff task that will scan my everything which is my infrastructure as a code. So we'll check, for example, the Docker file in this case, but we could check like Terraform, CloudFormation, ARM template, biceps, Kubernetes definition, Helm chart, this kind of stuff. And we'll send the report to the Prisma Cloud Console, and we will see, and there we can check what was wrong, is there any misconfiguration, and so on. And of course, in this case, I have some misconfiguration, but I did a soft fade through, so just to be sure that my pipeline can continue and we can go to the second phase. And then here we are building the Java application. We have some cache, Maven cache. And here we bring the dependencies. And here with this line, here we will scan the code repo for the code for the vulnerabilities inside the code dependencies. So we bring a lot of vulnerabilities, a lot of, hopefully not vulnerabilities, but a lot of dependencies in our code. But then with Prisma Cloud, we'll be able to scan those dependencies, and we'll send the result again to the Prisma Cloud Console. Then we build the image with Docker build, and then we can do the sandboxing. And this is the command that we'll use, just sandbox. And here, for example, I think I scan it for 10 seconds. You know what, maybe I will modify that, otherwise we'll wait for nothing. But we scan it for 10 seconds, for example, and then you pass a couple of environment variables if you need to start your Java application in this case. And then you pass also what is the jar that he has to start, for example. And here, we'll scan for the vulnerability. So if I push this code, modify the sandbox, I will trigger a new pipeline. And if I go to GitHub action, you will see here that it will run for a couple of times. But OK, maybe I can show you already a fake pipeline here. So if I connect here, we'll see here the different tasks. So first was checking the infrastructure as a code. So here we have the task from Prisma Cloud, and you have the Docker file that has been scanned. And for example, here, maybe the interesting part is a user for the container has not been created. So that means in our Docker file, we don't have like a user statement. And then if it is built like this, it will run as a root, which is not best practice. So that's why we bring a failed check. And here, for example, I have a Docker file, but of course it's like an example. But we have like an AWS access keys inside the environment variable. And then that will also allow you to see that, for example, on running time, we can spot this kind of misconfiguration, because we'll see that there is an environment variable, password, and stuff like that. If you click here on the link, you will be sent to the report to a Prisma Cloud console to see what are the misconfiguration of that specific file. So just like this is the platform, and you see that you have like the AWS access keys, which is spot on, and then the health check instruction that have not been created, and the user issue. So this is what we can do for the infrastructure as a code. And then anybody knows checkoff already? So checkoff was like nice on the back. So checkoff was it's like an open source project that we and it was part of Bridge Crew. And Palo Alto did the acquisition of Bridge Crew like 2 years ago now, more or less. And now it's fully integrated into the Prisma Cloud platform. So it's that's a bit the idea. But so Checkoff can be like is an open source and will remain an open source tool. So the only thing that you cannot do with Bridge Crew is, of course, having access to the platform. But then you cannot create custom policies. But otherwise, you will be able to do the scan of infrastructure as a code. So that's something you can really easily start with, just with a pip install checkoff, and then you can scan your Docker file, your Kubernetes definition, and so on. So it's really worth to check. And I think out of the box from checkoff, we have like 2,500 policies, something like that. So if I come back here on the Prisma Cloud, you will see that I have a check which is checking the code dependencies, and which is here, repo vulnerability scan. And here I just the command I showed you before is twist CLI code repo scan, and then we send the report to the console. And here we see all the different all the different vulnerabilities that we bring into the different code dependencies that we have. Right, then what we can do. So the idea is that we also provide feedback to the developer really in his environment. So either we can do it already in the VS Code, I will show you that in a moment, but we can also do it inside the CI/CD. So it doesn't have to connect to an extra tool, which would be in this case Prisma Cloud. You get the result already in the CI/CD. Here we can do the sandboxing. So we start the web app, the Java Spring Boot, and then we, in this case, I started like for 30 seconds, but here we run the web app for 30 seconds, and then we learn everything that happened on that specific web app. And for example, if I take an example here with where I have a malware in that image, so the idea is that then we send a report to the Prisma Cloud, and here you can see that we detect that this machine starts this kind of process at the starting of the container. Then we have all the network connection that was established, and then you can wonder, why I have a connection going to the France, but to France, and then you can see that basically the DNS query was pool.mineximr.com, which is like something for crypto mining. And that's what you see all the suspicious finding here. You see that we discover that we have this file, which is malicious, and brings some, is classified as crypto miner. So that's why, doing the sandbox could be super helpful, especially for if you bring images from a container registry or from a third party that you don't, third party you should know, but a container registry that you don't know, for example. All right, and then the last step is checking the vulnerabilities of the image. Here I took an image which is highly vulnerable just to have a demo and make sure that I fail my pipeline. But then again, you can have the result inside Prisma Cloud. What is really interesting is the fact that we can also integrate into VS Code. So you install checkoff, and for example, in this case, you will, here I have a requirement.txt, maybe not readable enough. I have a requirement.txt, and when you go, you see it's like underlined in red, and you see that this Flask requirement, for Flask dependency, that specific version has already 2 high vulnerabilities. So maybe it's good that you upgrade to a different version, and we'll check again if the new version is fine or not. And then I told you that we can scan the infrastructure as a code. So in this case, it's a Docker file. And here you can see that we have a Python base image. And basically, we'll scan the Docker file directly, like what is the content of the Docker file. And in this case, we can see that a user for the container has not been created. So it's exactly the same error that I showed you before in the Prisma Cloud platform, but we send it already on the developer seed. So he sees it, and maybe he can decide to do something about it. And if he doesn't know what to do, then he click on the link, and the link brings him to the documentation of Palo Alto Networks to help him to create like a user statement and this kind of stuff. The other part which is interesting here is a bit below of the low. I'm not sure I can move my mouse here, but we see that with checkoff, we will scan the base image, so the Python 3.7, and we can see that there is already 3 critical vulnerabilities. So that's why there we can maybe, okay, fine, we will suggest to the developer, okay, you should change of a version, and he can go to a different version. And the last stuff we can do here in the VS Code is scanning the secret. So here we detect that this is an AWS access key, so we provide already feedback to the developer. All right, any question on that? I don't know. Not yet? All right, I prepare some swag here. If you have any question, the first that asks a question. Sorry? Yeah, so the question, if I understood correctly, and maybe I will go back. Oh, yeah, no, the camera is following. Nice. So maybe there, if I understood the question is, can we send the, yeah, can we, what was, yeah, sorry, can you repeat the question? You just, sorry. Yeah. Yeah, as a matter of fact, yeah, that's what I understood. So the question is, just to repeat for everybody, is can we scan the file in VS Code, then if I understood correctly, can we scan the file in VS Code directly? As a matter of fact, this is really what we do. So we have here, like for example, the Docker file, or maybe I will take this requirement that take the other application, so it's going to be easier to scan. So for example, here, when I will do like, okay, I want to use the 1.0 now, and you can see that here on the bottom, checkoff is running, and basically we'll check if that specific version is compliant or not. And it's still running, but the 1.0 I think is not compromised anymore. Then we will not have the warning anymore. All right, so here you see it's good. So here we don't have a warning. Okay? Thank you for the question. You deserve a swag. And so yeah, maybe what I want to show you now is about the fact that here we can, on the VS Code part, we cannot really enforce. We can suggest changes, but we cannot really enforce. So that's why you have the CI/CD integration, because there we can fade the pipeline, and we can make sure that we don't ship any container images vulnerable into production or development environment or something like that. The idea also that we have is that we can connect to whatever organization you are using, like GitHub, GitLab, Bitbucket, Azure DevOps, this kind of stuff. We can connect to the organization. Then we'll scan all the repository that you have there, and we will scan only the files which are interesting for us, because we focus only on infrastructure as a code and code dependencies. So in this case, my Java Spring Boot application I showed you just before, we have a Docker file and we have a pom.xml. So we'll scan those. Here, what we'll learn is that the pom.xml brings this kind of first-level dependency. However, those one will bring other dependencies. And for example, here you can see that there is like multi-chaining dependencies. And here, if I click on this one, you will see that you have in the error tab that you have this package version, which is for the, in this case, I think was for the MySQL connector. So basically, you are running the MySQL connector 5.3.13. You should upgrade it to the 5.3.18. And here we give you like, which is coming from the public information, like a database. We give you like the remote, we tell you that it's a remote execution. The attack vector is network. And the attack complexity is quite big. So that means just a web call to the application, and then you might be compromised, but the complexity of the application is quite big, so yeah, not everybody can do it, obviously. All right, so this is what we can do here in the application. We will discover the vulnerable, all the dependencies, and what is also like a big subject for the moment is to generate SBOM. So for example, the software bill of material. So just by going to the application, we'll be able to generate your SBOM for open source packages, infrastructure as a code, and images. And then you can, you have the XML, you can import it in a different tool later on, and you can select like the different repository that you have over there. Then you download, and you have the XML. What I want to show you as well is the fact that here, for example, on the Java Spring Boot, we detect like the MySQL connector is like vulnerable. And here we are using the 8.0.28. And here we have another application using like different, which is vulnerable as well. And we have like different vulnerabilities. And so if we take the biggest one, so this is, and Prisma Cloud will recommend you should upgrade to that specific version, which is not vulnerable. And here we see that this CVE was solved in that version, but that doesn't mean it solved the other CVE. So maybe if you click the highest one, it will tell you, okay, this one is good, because this CVE is fixed also in that one, and this CVE is also fixed in the 2.1.210. Then you can also select this one, and you click on fix, then fix, you submit, and it will open a pull request to your code repository automatically with the proposition of all the change that we commit here. Here, we see also the misconfiguration of the Docker file and stuff like that. All right, so that's a bit, and if I come back, maybe on that slide, and that's what I show you here is this part. Everything that we can do in the code and build. Then we have a bit of image analysis sandbox. And then what I would like to show you now is more the running. So what we can do in the runtime, if I go in my Prisma Cloud console, all right. So what we can do here is basically the idea is that we have what we call a Prisma Cloud Defender agent that can be deployed either on Kubernetes, could be like on the OpenShift cluster, but we can also deploy it on serverless function, like Lambda, Azure function, and also virtual machine, like a Linux, VM Linux, Linux VM or Windows VM. We can deploy an agent there, and it will scan the workload where it's running for vulnerabilities and compliance issues. So for example, in this case, I deploy on my Azure Kubernetes cluster, and I have the white space are the namespace, so you can see the name of the namespace. And here I have a namespace log4j, Swagger API, and so on. So here, what I have, if I click on that specific image, that's all the image running in that specific namespace. But then I can see, if I click on it, I will see all the vulnerabilities of that image. If I click here, we can see that I'm running the log4j 2.14.1, and it should be upgraded to 2.16.0. if I go on the compliance tab, I have all the compliance issue of that image. It's again the same issue that we had before. So the image has been as a root, and here we check for the running images that it should not be running as a root. So that's the information we get here, and then we give you like some kind of description, a bit of help. If a user is already defined in the container image from the Docker file, then you don't run it as a root. In the layers, we give you per layer what are the layers that brings the vulnerabilities, which could be like very interesting because then like a security owner or something like that, or already like the developer working in a Prisma Cloud, he knows where to fix the vulnerabilities. He knows where to work on which part of the Docker file to fix the vulnerabilities. So it's really like about coaching, helping to better secure their infrastructure. Then we discover all the process that have started during the boot of the image and that we monitor during the lifetime of the image, and we have the package info that give you like all the package that have been installed in that on that specific image, and then we look also for the jar, and here, if I don't mistaken, is an Alpine image, and here you will see all the package that was installed with APK install and stuff like that. And you see the version, and you see the number of CVE, which are known per those package. All right. Yeah, last stuff. Yeah, I think I explained everything here. I told you that we can install it also on the virtual machine. I have one example here with an EC2 instance, which is running, yeah, obviously on AWS. So we get the list of the vulnerabilities of that specific machine. And then what I want to show you here is the compliance. Because we can check the compliance posture of every workload, and we'll scan it every time. And by default, you can see that I'm running Amazon Linux 2. So by default, Prisma Cloud now it has to apply the CIS, so the compliance framework, and it will check like the information on the virtual machine itself. So if you click here, you will see that ensure that the SE Linux state is enforcing. And obviously, we failed that check. It's not enforced. So here you have a recommendation that you should enable it, enable the SE Linux. This is what we can do. The last, not really the last, but something I want to show you as well is if you go to vulnerabilities, you come here in the Vulnerability Explorer, and you can search for a specific CVE. So when you have like log4j, or the next one that will come very soon, you search for the CVE, and then you can just click here on the link, and it will tell you everywhere that specific CVE is running. So here we have deploy images, and you can see that this Docker image, container image, is running in the namespace, which is log4j. It's running for two different deployments, vulnerable application 1 and 2, and on that specific worker node. So then you know exactly where this vulnerability is running in your environment today. But you can know also here, and I'm not sure it's very readable, but we will scan also all the container registry. So we can connect your container registry with Prisma Cloud. And here we'll scan those container registry, and we'll report it. So if you have images at rest, which is built with log4j, which is vulnerable, then you will be aware over here. On the host level, for example, if you have a virtual machine running the log4j vulnerability, you will get the list of the VM over here, either Linux or Windows, and you can have also the serverless function. So that's what I wanted to show you. And I don't know if you have any question, like, why not? Yeah, please. Yeah, Opsgenie, I don't know it, but we do integrate with a lot. So you just create an alert. Then you can add a profile, and you select which one. And basically, you have like Jira, PagerDuty, Slack, and so on. And if it is not in the list, you can just use a webhook, and then we just drop a JSON, and you can configure some authentication stuff, and so on. And adding some payload also, like very customized. But we take the big names and like a Splunk, for example, ServiceNow, Security Hub from AWS, and so on. All right? And you can create a rule. This is kind of interesting because then on the vulnerabilities, on the deploy images, you can create different rules. And then you can say, okay, for example, on the deploy images, I don't want any images which are critical to be deployed in my Kubernetes cluster, and you will define here the scope. The scope is what we call a collection, and this is the collection. So it can be very precise. You can say, okay, for that specific cluster, I will apply this rule, but you can be also very precise in terms of, I want this image with this deployment name, for example. This is what I do here, but so then I have a policy that will apply only for those images, and then you can say that, for example, for the severity, I want to have a grace period for my developers. So they have like 7 days to patch for the critical vulnerabilities, and they have like 30 days for the high vulnerabilities. And then in the advanced option, what you can do is, in case you are filling a pipeline and you want to allow it, you can just add the CVE number and ignore it. Then, or you want to block it, a specific like log4j. You have a policy which is off for everything, but you want to add an exception and stuff like that. And when you ignore it, you can also provide a date. So you can really play with that and stuff like that. And then per rule, you can create an alert rule that you define, and then it goes to maybe this one is very critical, then it goes to pager duty and send an SMS to the guy which is on call, for example. This kind of stuff. All right? Any other question? Gilles? No. So maybe what I can show you is the serverless part. This is really something I like that we do. And I know that not everybody is already using serverless, but I guess some of you, so I will show you anyway. So what we can do here is we can connect to a different cloud account. And here I have an example on AWS. But what we do, we connect to your cloud account, we scan all the Lambda function, Azure function, whatever, and then we will discover what are the triggers and what are the service which is used by those Lambda functions. And so, for example, here, you will see that you have some CloudWatch events, S3 bucket, SNS topic, and here we have a function which is vulnerable, and you will see that here what are the vulnerabilities which are which are used by this Lambda function. Then you can expand it. You can see that, for example, this node UUID is using 1.4.3, and it has been fixed in 1.4.4, for example. Then you see the compliance issue. And this is also what I wanted to show you, is that we can detect the fact that you provide a role to a Lambda function, which is which has like too many permissions, and it does not use those permissions. So, for example, if you give like access to S3, you attach a role to a Lambda function that give access to a SNS S3 bucket, but at the end it's only using S3 bucket. Then you can. That's why you have like overly permissive permission, and then of course it can create some risk in case that Lambda function is compromised. And that brings me to the fact that we can, on the running and the complex identities I already mentioned, we have like a module which is EAM security. And what we can do here is, for example, if I go and investigate, we can create some query. And the query will query Prisma Cloud, will query your cloud account, and will give you a graph. And for example, in this case, I'm looking for EC2 instance that have access to an S3 bucket. And here, if I expand them, I will see the list of all the EC2 instance, which has access to different role and the S3 permission that we have. So that means, for example, if I want to know what are the EC2 instance that has access to this specific S3 bucket, I can just go over it and then give me what role and what are the instance. What I can do as well is give me all the Lambda function, just to stay on and I always do the typo like this. So what are the Lambda function? I need to click. What are the Lambda function and what are those permissions from the Lambda function? And here, you will see the different Lambda function, the name of the different Lambda function. And here you can click on it. and you will see all the permissions that they have. So for example, in this case, we have SQS, which is pretty well defined, so it should be okay. And here we have wildcard permission. So this could be like a risk. If you have like a Lambda function which is too permissive, then it will it might be like access to like extra privilege and so on, or maybe like especially if you assign like administrator access to a Lambda function, then you have access. If it is breached, then from that Lambda function they can do a lot. So and here, what I have. So just to show you another example with maybe a bit more data. Yeah, I took the same. Yeah, let me remove this. All right, let's take. Yeah, but anyway, the idea is that here we, again, like DynamoDB, and so we really provide a view on a different access that have your different services. And then you can query like Prisma Cloud for user, for an access keys, and this kind of stuff. And you get really a good view, and out of the box will come with different policies that will trigger an alert in case of overly permissive. So for example, if you have a Lambda function that has access to more than X services, we'll give you an alert. Maybe it's a false positive, then you can snooze it, you can adapt the rule and stuff like that. So yeah, I'm open for any question. That's a bit my talk, and I hope you enjoy it. And yeah, feel free to ask any question if you have. No question? Tell me.
Do you have like an overview, maybe per team, like with a summary and then maybe some score, how different, I don't know, areas or teams performing?
Yeah, good question. Thank you. Yeah. As a matter of fact, we do. So if you go to the development pipeline, it's not very per team, it's per repo. So you know which repo is like going well or not, and we give you the list of what are the vulnerabilities from a specific repo and so on. And here in the code review, those are all the scans that happens inside the CI/CD time, but also when you use checkoff, and you have the API key to connect to Prisma Cloud. Then you can connect from there, and you see what are, for example, here. If you go over it, I think it's here. You see the number of vulnerabilities that you have and stuff like that per scan that you that we do. I think it's maybe here. Yeah, and you see like enforcement and stuff like that. So this is, but it's not very per team. It's per repo and per organization and so on. But you have this kind of view. But I guess you have each team has its own repo, right? All right. So could be like maybe helpful in your case. I don't know. Any other question, guys? No? So yeah, thank you for your time. Feel free. I have a thank you.